today's section is P.6, and it's the errors in the algebra of calculus. All right, so we're just going to be looking at a lot of errors today and trying to find out what the mistakes are, and then also working a little bit backwards than what we're typically doing, because we'll see that it does come in handy once you get to calculus. So the first thing is the errors in algebra, and it's the best way to avoid errors is to work slowly and not skip steps. So I don't think that could have been any more evident than these past few sections that we've done, especially P5. Because as I told you at the beginning of the year, a lot of these questions are going to be very long questions, and so the best thing to do is to take your time, show all the steps, so that way you don't miss anything or make any small errors. So for our first example, it is just asking us to find the errors in this problem. So the first step is sort of here to the left. So that's the first step. So we look at it and we say, okay, it was 3 times the quantity x minus 1 squared. What they did, they distributed the 3 to the x minus 1, and then they took that binomial and they squared it. So we have to say, okay, what error did they make? Well, if you remember back to when Tuesday's lesson on P5 day 4, I think it was, one of the problems we went over, I said, be careful, you don't want to make this mistake, and it's the mistake that they made. So we have to remember order of operations. Exponents should be done, or they come before multiplication. Okay, because distributive property is just multiplication. So right here was the error. We don't like that. So if we are to do this problem, we are going to just keep that 3 out front, and then we are going to square this, which means we're going to multiply by itself, or FOIL. So we get 3 times x squared minus 2x plus 1. And then I'm going to go through and distribute the 3. So then it becomes 3x squared minus 6x plus 3. Okay, so finding that error. All right, so you guys pause the video, take a second, think about the your turn, because it really only takes a second to think about it, and then come back and unpause it and we'll go over it. All right, so hopefully you did it. And the error that they had is they added the denominators. Okay, they took 2x plus 3x and got 5x. But we all know that we can't do that when we add fractions. We have to find a common denominator. And then once we have the common denominator, we only add the numerators. We don't add those denominators. So, whoops, let me cross that off, not highlight it. Our common denominator would be 6x. So this one here would be a 3. The second one would be a 2. So then if we added, it would be 5 over 6x as your answer. Okay. Simple enough, right? All right. In the algebra of calculus, it says some standard algebraic techniques are employed in calculus which usually involve unsimplifying. All right, so it's like working backwards in a way. So you've always been told simplify, 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 and now I'm saying, okay, well, sometimes it's a little bit easier if we unsimplify things, or we just go to the step before we completely simplified. So that's what we're going to work on here for these 3 problems. The directions say to write each quotient, because quotient is division, as the sum or difference of terms. So what that means is we just need to split this up. So remember, whenever of course, I didn't do it for this one problem, but I know I did it the other day. Technically, I should have done this and then went to there. So the step before my last step is them being a separate fraction. So that's what we want to do here. I want to rewrite this as 3x over x plus 4 minus 7 over x plus 4. and then look and say, okay, is there anything else I can do to maybe simplify that before we move on? The answer is no, so that one's done. Okay, and trust me, once you get to calculus, you'll be like, oh, I remember doing this in Algebra 3. All right, the next one. 2x squared over x minus x over x plus 5 over x. Again, simplify if possible. So here we would have 2x minus 1 plus 5 over x. That would be acceptable, or sometimes you would see it as 2x minus 1 plus 5 times x to the negative 1. So it just depends if we need to write it with a negative exponent or not. So you wouldn't need both, just one of them. If they specified write with a negative exponent, then do that. If not, then the first one's fine. I will generally accept either one. All right, and this last one, look how fun this one looks. So again, I'm going to separate this. But one thing I will say is, since I automatically see x values in the numerator and this radical in the denominator, but under the radical is an x, I am going to rewrite that denominator as to the 1/2 power whenever I split this up. So this is going to be 5x cubed all over 2x to the 1/2 power plus 2x squared over 2x to the 1/2 power minus 9x over 2x to the 1/2 power minus 6 over 2x to the 1/2 power. All right, so now when I divide like bases, we subtract the exponents. So this first one is going to be, I'll just write it as 5 halves to the x, or x to the 3 minus 1/2. And that gives us 5 over 2 x to the 5 over 2. You need to sort of do that off to the side. I mean, you guys should be getting really good at doing this. That's how I got my 5 over 2. Or you can just plug it into the calculator. The next one, whoops, my screen moved. My 2's cancel. So I'm just left with x to the 2 minus 1/2. So that's x to the 3 over 2 power. 9 halves, that doesn't reduce, but I'm left with x to the 1 minus 1/2. So that's 9 over 2 times x to the 1/2 power. 6 over 2 reduces to 3, but here's where we have to be careful, because that x to the 1/2 is in the denominator. So we could leave it there, or we could rewrite it as x to the negative 1/2 power, whichever you prefer. And now I'm looking at all of these exponents, because my variables are the same, they're all x's, but all of my exponents are different, which means none of these are like terms. So there's nothing else I can do to simplify this. So we are done. And you're probably thinking, oh, this looks so much better before we did all that. And I agree, but sometimes there's need for this. All right, so take a moment, pause it your turn. I'm going to just write the answer for you, that way you can check it. All right. And last but not least, we've already sort of did it in the last problem, but we are going to, there's 2 more. We're going to rewrite each expression using negative exponents. So down here's my exponent. It's positive in the denominator. So all I'm going to do is move that expression to the numerator, but when I do that, it becomes a negative 6. And that one's done. For the second one, I'm just going to move everything to the numerator. If it's a variable in the denominator, we move that variable to the numerator, and whatever the exponent is becomes positive. So we get 5x to the negative 2. Don't forget this right here has an exponent of 1/2, so it becomes plus 3 times x plus 2 to the negative 1/2 power minus 1/4. Let me rewrite that. Here we go. X to the negative 1st power. And that's it. All right, our last problems. It says factor each expression. And even though it doesn't look like it, the 5/2, the 3/2, and the 1/2, they are all exponents. So just like when we were factoring out negative exponents a few lessons ago, we factored out the smallest exponent. We want to do the same thing again. So let's factor out smallest exponent. Okay, we will write that again just to refresh our memory. So the smallest exponent is 1/2 because I have an x, I have an x, and I have an x. So x to the 1/2 is the smallest. And then again, we have to go through and subtract what we factored out. Okay, so let's go through and do that. So x to the 1/2 is out front. 5/2 minus 1/2 is 4/2. But if you think about that, that's just 2. So I'm left with x squared minus 5x. 3/2 minus 1/2 is 2/2. 2 over 2 is just 1, so I don't need to write that exponent. Plus 1/2 minus 1/2 is 0. X to the 0 power is just 1, so I'm just left with 8 there. Okay, it says factor each expression, so I'm going to say, okay, I need 2 numbers that add to give me -5, but multiply to give me 8. 1 and 8, 2 and 4. We look and say, oh, no, that can't be factored at all, so that trinomial is prime, and we're done. All right, and the last little piece here is they want us to factor this expression. And if you're anything like me, you're sitting here thinking, okay, it's a trinomial. Don't write this down right now, just as a heads up. I need 2 numbers to add to give me -1, but when I multiply them, I get 3/4. Well, that doesn't sound like much fun, to find 2 numbers when I multiply to get 3/4. So let's make our lives a little bit easier. Let's forget about that traditional way to factor trinomials and say, I don't like that 1/4, so I'm going to factor the 1/4 out. And we did this towards the beginning. So I'm going to factor out the fraction of 1/4. So factoring out is the same as dividing. So dividing by 1/4 is the same as multiplying by its reciprocal. So it's like I want to multiply each term inside by 4. So I end up getting 12x squared. Whoops, I need a minus there. A minus 4x and a plus 1. And then I had better double check before I move on. I need 2 numbers to add to give me -4, but when I multiply them, I get 12. So 1 and 12, 2 and 6, 3 and 4. Well, 2 and 6 work. If I do a -6, they work there. But if I look, they don't work there. And no other combination could make that work. So that means that is unfactorable. So it is prime.